are two major subtopics, okay? The first one is, 4.1 is similar plane figure, okay? Similar plane figure. Okay, 4.1 is similar plane figures, and 4.2 is perimeter and areas of similar triangles. Okay, perimeter and areas of similar triangles. So in this unit, we have two major subtopics. The first one that I mentioned here, similar plane figures, and the second one is perimeter and areas of similar triangles. Okay, today we will have a discussion on the first part of on the first topic of this unit, which is about similar plane figures. Okay, so let's formally state what similar plane figures refers to. If we have two figures, and if we move one figure onto the other in such a way that a figure fits the other figure, then we can say that the two figures are congruent. Okay, I repeat it. If we move one figure on another, and if the two figures fit each other, or if we are able to make the two figures fit, then those figures are congruent. Here in our discussion, we use different symbols like this symbol equal and something on upper, which means congruent, and we use this symbol to say similar. Okay, so as I've said earlier, two figures are congruent if one exactly fits the other, or if the two figures have the same size and the same shape. And every congruent figures are necessarily similar, right? But in some cases, we may have different figures having the same shape but different size. These kind of figures are similar, okay? Similar figures need not necessarily have the same size, okay? So the necessary condition for two figures to be similar is they need to have the same shape. So now let's see some examples of similar figures. For example, if you see a tree and its shadow on a flat surface, clearly a tree and its shadow only on the flat surface. If the surface is not flat, the shadow and its tree may not have the same shape. Okay, so this can be a good example. Okay, you can take a tree and its shadow; they are similar. You can also take a building and its shadow. Okay, they can be a good example of similar figures, right? You can also bring some examples of figures which are not similar. Like if you consider your own picture at the age of 5 and at the age of 20-something, those figures may not, or those photos may not be similar, right? Because there is a change in shape. Okay, literally, the two figures are said to be similar if they have the same shape. We don't care about whether the size are the same or not. Okay, shape is very important. So in our discussion here, we will have a formal definition that represents similar polygons. Okay, so let's focus on similar polygons. Okay, if we have two polygons, we can construct a definition of similarities. Okay, two polygons are similar if two conditions are satisfied. Okay, there is a necessary and sufficient condition for two polygons to be similar. One of the condition is the pairs of corresponding angles are congruent. Okay, whenever we compare two polygons, and whenever we compare two polygons, we need to consider two conditions, necessary and sufficient condition to say the two polygons are similar. So one of the condition is the pairs of corresponding angles of a polygon should be congruent. Okay, this is one criteria. We have one more criteria. That is the pairs of ratios of corresponding sides are equal. Okay, so the second condition is the pairs of the ratio of corresponding sides are equal. So these two conditions are very important to say two polygons are equal. Okay, to clarify this definition, let's take a certain example of similarities of polygons. For example, consider the quadrilaterals given below. So one of the quadrilateral is a quadrilateral with vertices say A, B, C, D, and another quadrilateral with vertices E, F, G, H. Okay. Now these two quadrilaterals are similar, or we can say these two quadrilaterals are similar. One, the pairs of the corresponding angles must be congruent. That means angle A and angle E must be the same. Okay, so you can put like this. The first condition, angle A must be congruent to angle angle E. At the same time, this angle B must be congruent to angle F. So you need to write it like angle B is congruent to angle F. The third one, this is G, okay? So angle C must be congruent to angle G. Angle C must be congruent to angle G. And lastly, this angle D and H must be the same. All right. So this is one of the criteria. Okay, you need to add one more condition to properly say these two quadrilaterals are similar. Okay, the first condition is not enough to say these two quadrilaterals are similar, right? So the second one is, according to our definition, the second condition to say these two quadrilaterals are similar if the ratio of the corresponding sides are equal. That means AB over EF, AB over EF is the same as BC by FG, BC over FG, okay? This also the same as DC over HG and AD over EH must be the same, EH. Okay, look, whenever you are calculating the ratio of the pairs of corresponding sides, if all these are not the same, if there is one ratio which is different from the other, the second condition fails. In this case, you cannot say that the two figures are similar, right? So these two conditions are necessary and sufficient condition for any polygon to be similar. Okay, having this in our mind, we will try to see different plane figures and identify the pairs of figures as similar or not, right? So the other important thing that you need to know here is the ratio of all these things is usually denoted by K, and this K represents proportionality constant, okay? So you need to be familiar with this thing. So let's see an example. Determine whether triangle ABC and triangle DEF are similar or not. Similar or not. Given that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F, where the figures are like here, A, B, C, and the side of each length is, this one is 3, this is 4, this is 6, and we have another triangle with vertices DEF, okay, DEF, okay, we have ABC and DEF. The sides of the second triangle is 4.5, and this is 6, and this is 9. Okay, now here we have two triangles, triangle ABC and triangle DEF. What is given here, the corresponding angles are the same. That means angle A and angle D is the same, is given. The other information is angle B and angle E are the same from the given information, and the shared angles C and F are congruent. Okay, these all are given. The other information about these two triangles is the side of each of this triangle is given. So based on this information, we are asked to determine whether these two triangles are similar or not. Okay, you need to remember the definition that I stated before. Okay, whether it is triangle or a polygon, there is a definition regarding similarities, right? So two triangles are said to be similar if the pairs of corresponding angles are congruent, one condition. The other thing, the pairs of corresponding sides, okay, the ratio of corresponding sides must be the same. So we will check whether these two conditions are satisfied or not. From the given information, we have this thing, so we don't need to check the first condition on the definition, because all pairs of corresponding angles are congruent, so no need to check the first condition on the definition. So the only thing that we do here is we need to check the pairs of corresponding sides, okay, the pairs of the ratio of corresponding sides are the same or not. Okay, if if triangle ABC is similar to triangle DEF, okay, if this is true, the pairs of corresponding sides, okay, the ratio of corresponding sides, AB by DE must be the same as BC over, okay, if you take this one, you take this one, then whenever you take BC, you take EF, BC over EF, and the third pairs of ratios, AC over DF, okay, DF. Okay, we need to check that whether these ratios are the same or not. If all these ratios are the same, we can say that these two triangles are similar. But if we get one value which is different from the other, the second condition fails. That means the two triangles are not similar. So let's keep calculating this ratio. What's AB over DE? Okay, AB is given that it's 3 and DE is 4.5. Okay, always it will be very good if we are able to simplify the given number. Okay, so let us rewrite this thing in more simplified form so that we can easily compare the ratios. 3 over 4.5 is the same as 30 over 45, right? And you can write 30 as a product of 2 times 15, and 45 can be written as a product of 3 times 15. So this can be simplified to 2 over 3, okay? Now we have AB over DE is 2 over 3. Again, let's calculate the ratio of the middle term. That means BC over EF, okay? Now BC is 4, okay? BC is 4, and EF is 6, okay? We have 4 over 6. So you need to write this 4 over 6 in the least simplified form so that we can easily compare all the ratios. So the simplified form of 4 over 6 is, 4 can be written as 2 times 2, and 6 is 2 times 3. So this is 2 over 3. Look, the first two ratios are the same, so we need to check the third ratio. If the third ratio is also the same as 2 over 3, then our conclusion will be the two triangles are similar. So let's see what AC over DF looks like. AC over DF is AC is 6, and DF is 9. Okay, now you need to write this thing in the least simplified form so that we can see whether they are the same or not. So 6 is the same as 2 times 3, and 9 is the same as 3 times 3. So now this can be simplified to 2 over 3. Well, as you can see here, all the ratio of the corresponding sides are the same, which is 2 over 3. Okay, so the second condition for similarity is satisfied. Already from the given information, you don't need to check the first condition because it's already given that all pairs of corresponding angles are the same. So the only thing that remains here is we need to check the ratio of the corresponding sides. So all these ratios are the same. Therefore, we can say that these two triangles are the same. Okay? Therefore, triangle ABC is similar to triangle DEF. Okay? So this way we can check whether two triangles are similar or not. Okay, this principle is not only for triangle, it works for any polygon, right? So any polygon should satisfy those two conditions to be able to similar. So let's see another example. The sides of a quadrilateral are 3 centimeter, 4 centimeter, 5 centimeter, and 6 centimeter. Okay, the sides of a certain quadrilateral is given 3, 4, 5, and 6 centimeter respectively. Okay, a quadrilateral means a 4-sided polygon. Okay, you need to know this one. So this is given. Find the sides of similar quadrilateral whose smallest side is 6 centimeter. Okay. Before we proceed to the calculation part, we need to understand what the problem is saying. There are two quadrilaterals, okay? There are two quadrilaterals which are similar. The side of one of the quadrilateral is given, that is 3 centimeter, 4, 5, and 6 centimeter respectively. Then the question here is, we are asked to find the sides of a similar quadrilateral whose smallest side is known. Okay, the smallest side of a certain unknown quadrilateral is 6. So we are asked to determine all the sides, right? So we need to find the other 3 unknown sides of a similar quadrilateral. Okay, to answer this thing, you need to apply the definition that I already stated, right? So by similarity of the two quadrilateral, we mean that the ratio of pairs of corresponding sides are the same. So that is what we need to apply to find the unknown sides. So let's say, let 6, x, y, and z are the sides of the quadrilateral. Okay, here 6 is already known. One of the side of the unknown quadrilateral is known, the smallest side of that quadrilateral. So you have to properly put all the variables and the known information. So 6, x, y, z. Why this 4? Because it's a quadrilateral. That means it's a 4-sided plane figure, right? So if we are able to represent the unknown variables by the unknown sides by x, y, and z, the next step is we need to equate the pairs of the ratio of corresponding sides. So that means the smallest one here is 3, okay? 3 over the smallest one here is 6. 3 over 6 must give us the ratio of the second side by the second side of the unknown quadrilateral. So this becomes 4 over x, okay? So by definition, you will have this ratio. Similarly, all the pairs of corresponding sides, okay, all the pairs of the ratio of corresponding sides must be the same. So the 3 over 6 must be the same as the third side, which is 5 over y, okay, 5 over y. Lastly, the ratio of 3 over 6 or 3 over 6 must be the same as 6 over d, okay, 6 over d, right? So this happens because of the definition of similar polygons. So the next step is you need to calculate all these equations and obtain the unknown variables. Okay, take the first one. From the first one, you can crisscross it. 3 times x, okay, this tells us 3 times x must be the same as 6 times 4. 6 times 4, okay? So 3 times x is 24, okay? So dividing both sides by 3, we get x is equals to 8, right? The value of one of the side of the unknown quadrilateral is 8. Okay, next we calculate the second equation. You can take simple crisscross, okay? Whenever we crisscross it, 3 times y is equal to 6 times 5, okay? This gives us 3y is equal to 30, okay? 6 times 5 is 30. Now divide both sides by 3 and obtain value of y. So whenever you divide both sides by 3, okay, you get y value, which is 10. Okay, we have the value of y. And lastly, we need to crisscross the third equation and obtain the value of z. So 3 times z is equals to 6 times 6. Okay, so this gives us 3d is equal to 36. Now divide both sides by 3, then you will get z is equals to 12. Okay, so here we have x, y, z. Therefore, all the sides of the unknown quadrilateral are obtained. Okay, so those two quadrilaterals are similar. Therefore, the sides of the quadrilateral are 6, which is already known, 8, 10, and 12 centimeter. Okay, this is the required answer in this example. So let's see another example which is very similar to this, so that you will have a good understanding of determining the unknown similar plane figure, right? Six centimeter, 7 centimeter, 9 centimeter, and 10 centimeter. Okay, the sides of a certain quadrilateral are given 6, 7, 9, and 10 centimeter respectively. Find the sides of similar quadrilaterals, quadrilateral whose largest side is largest side is 30 centimeter. Okay. Just to remind you what we did in the previous example. In the previous example, a certain quadrilateral was given, and you were asked to find the sides of unknown quadrilateral whose smallest side was given, okay? In this case, the question is a little bit changed. There is a certain known quadrilateral whose sides are 6, 7, 9, and 10, and you are asked to find the sides of similar quadrilateral whose largest side is 30 centimeter, right? So we will follow the procedure that we have seen in the previous example. That means we need to apply one of the condition of similar plane figures, right? So this is how we do. Let the sides of the unknown quadrilateral are X, Y, and the largest one is known, which is 30 centimeter, right? You can represent all the unknown sides by a certain variable, X, Y, Z. Then the next step is you need to properly apply the condition for similarities, right? So by definition, the ratio of the corresponding sides must be the same. That means 6 over X must be the same as 7 over Y. This must be the same as 9 over Z. And lastly, we have 10 over 30. Okay, these ratios must be the same. Otherwise, you cannot say the two quadrilateral are similar. Since it says the two quadrilateral are similar, these ratios are the same. That is the first thing that you need to do. Now let's take a pair of ratios and solve each variable separately. So take 6 over X and 10 over 30. Okay, 6 over X must be the same as 10 over 30. The other thing that we can take from this equation is 7 over Y and 10 over 30 are the same. Okay, 7 over Y and 10 over 30 are the same. The third one that we can take is 9 over Z. 9 over Z is equals to 10 over 30. Okay? So as we did in the previous example, the only thing that remains here is crisscrossing each of the equation and obtain the unknown variables. So from the first one, multiply 6 times, or you can simplify each of these things, okay, so that our calculation will be more easier. So calculate or crisscross each of the equation. 6 times 3 is equal to X. So this implies X becomes 18. Okay, so we have one of the side. The second one, you can use crisscross. Okay, crisscross it, then Y becomes, or 7 times 3. 7 times 3 is equals to Y times 1, which is Y itself. So the product of these two numbers is 21. So Y becomes 21. Okay, Y becomes 21. And from the third equation, you can use crisscross. Then 9 times 3 is equal to Z times 1, which is Z. So the third unknown variable becomes 27. Okay, so we obtained the unknown variables X, Y, Z, which are the unknown sides of a certain quadrilateral. So you can say that, therefore, the sides of the quadrilateral the quadrilateral are 18, 21, 27, and 30. So this is how you determine similar plane figures. It can be triangle, it can be quadrilateral, it can be pentagonal plane figures. Okay, whenever you are interested to check whether the two polygons are similar or not, don't forget to properly apply the definition that I already stated. Okay, those are, the first one is you need to cross-check whether the pairs of corresponding angles are congruent or not. The second one, you need to cross-check the ratio of all pairs of corresponding sides are the same or not. Okay, this is how you check whether two polygons are similar or not. I hope you enjoyed the lesson. In the next lesson, I will bring some more interesting examples on similar triangles. This is enough for today. Thank you for listening.